In this question, we need to describe a sequence of transformations which maps the graph of y equals mod 2x minus 1 onto the graph of y equals mod x. These kind of questions often catch people out. What I'd like you to do is pause the video and have a think just for a few seconds. What is it about this question that you think might catch people out? Okay, the thing that often catches people out with these kind of questions is that we are transforming from a more complex function to a simpler function. And if people are on autopilot, they will typically start with the simpler function and translate onto the more complex function. So it is important to make sure you're focused enough to spot that. So how do we approach this question then? You might want to think of it as going from the answer back to the question, and you've got to think, how do I undo all of these things around the x here? And so there's often more than one sequence of transformations that will do the job, but usually there'll be one set of transformations which is more straightforward than the rest. So I'm going to show you two possible answers to this question. One of them quite straightforward, the other a little bit more complex, and then we'll discuss how might you go about choosing the most straightforward set first time around. So in my first sequence of transformations, I'm going to deal with the 2 first. To undo this 2, I'd like to be dividing by 2. So that means I want to stretch scale factor 2 in the x direction. Let's apply the transformation. Replacing x by x divided by 2 will give me 2 divided by 2, which will cancel to give x minus 1. Next, I'd like to deal with the minus 1. To undo the minus 1, it makes sense to replace x by x plus 1. That gives us a translation of vector minus 1, 0. Let's apply the transformation. This time we're replacing x by x plus 1. X plus 1 minus 1 just gives me x. So in my opinion, that's the most straightforward way of applying two transformations in this question. Let's have a look what happens if we try to reverse the order. This time we'll begin with the translation. However, we have to be a bit more careful here about which vector we translate by. You might initially think that to deal with the minus 1, you translate by minus 1, 0, because that would be replacing x by x plus 1. However, you need to remember the fact that whatever you replace x by, you're going to multiply it by 2. And so the translation we want is minus 1 half 0. Let's apply the translation to check. So I replace x by x plus 1 half. So if I expand this bracket, I get 2x, and then plus 2 times a half, so plus 1, minus 1, which cancels out to just leave y equals mod 2x. From here, it's relatively straightforward to finish. I want to undo the 2 by dividing by 2, so stretch by scale factor 2 in the x direction. Applying this transformation, we divide x by 2 to get y equals mod x. So now let's briefly explore how would I know which way is simpler. First of all, it's worth noting that if you approach it the way I did on the right hand side here and instead did minus 1, 0 for your translation, later in the question you would see that it wasn't going to work if you applied the transformations. And you could then go back and you could modify your answer to make it work. So even if you don't spot the easiest way to do it, you can still get to the answer fairly easily. It's just a bit of trial and error. But if you'd rather not go wrong to start with, the way to approach it is to think about what you're replacing. If I haven't first dealt with the 2, then if I try a translation, whatever I translate by, I'm going to have to multiply by 2. And so if you think carefully before you start about what you're going to replace, you might find that you're able to spot the most sensible order to apply the transformations in. Right, now it's your turn to have a go at one then. If you thought the example was quite straightforward, you might want to try and see if you can find two sequences of transformations. Pause the video and then come back and check your solution against mine. Welcome back, here's my solution then. My answer shows both ways of doing the question. The one on the left is more straightforward. The translation and the stretch are probably what you expect them to be by simply looking at the question. The answer on the right hand side is more difficult to spot, and it shows why it's so important to actually apply the transformations. So on the right, where we've applied the stretch of scale factor 1/3, I've replaced y by 3y, and then when I've divided through, notice I've ended up with 2/3 here. You might not have expected that unless you've got enough experience with these kind of questions. Okay, if you've got the question right, move on. If not, in the next part of the video, I'll explain how I got my answer. Okay, here's how I got my solution. In our function here, we've got 3 sin x plus 2. First of all, I'll deal with the plus 2. To undo a plus 2, I need to translate 2 units in the negative y direction. Let's apply that transformation. I need to replace y by y plus 2. Subtracting 2 from both sides gives me y equals 3 sin x. Next, I need to deal with the 3. To undo the 3, I need to stretch by scale factor 1/3 in the y direction. Stretching scale factor 1/3 in the y direction means divide y by 1/3. That's the same as multiplying by 3. So we replace y by 3y. And dividing through by 3 gives us y equals sin x. That's what you get if you do it the more straightforward way. Let's have a look what happens if you do it in the reverse order. This time we'll start with stretch scale factor 1/3 in the y direction. That tells us to replace y by 3y. I think this next part illustrates why it's so important to do the replacements, because otherwise it's really easy to miss things. If I now divide through by 3, I get y equals sin x plus 2/3. And if you don't apply the transformation, it's very difficult to see what the translation would need to be for the next part. So now we need a translation of 0 minus 2/3. That tells us to replace y by y plus 2/3. Subtracting 2/3 from both sides gives us y equals sin x.